Most people imagine the Big Bang like this: a tiny point, a sudden blast, matter flying outward into empty space, stars, galaxies, planets, everything rushing away from one central explosion. It sounds obvious, it even sounds like the name itself, the Big Bang. But here is the problem: that picture is almost completely wrong. The Big Bang was not an explosion inside space, it was the expansion of space itself. There was no center, there was no empty room waiting for the universe to expand into. And if you could somehow rewind the universe back to its earliest moments, you would not find a tiny fireball sitting in the middle of darkness. You would find something much stranger. Everywhere was hot, everywhere was dense, everywhere was the beginning. To understand why, we have to destroy the most common picture of the universe, because the Big Bang did not happen somewhere. It happened everywhere. When we hear the word explosion, we imagine something familiar. A bomb explodes in a room, fireworks explode in the sky, a star explodes in space. In every case, there is a center. There is a location where the explosion begins. Then debris flies outward into the surrounding space. That is how explosions work. But the Big Bang was not like that. There was no outside space for the universe to fly into. Space was not a stage waiting for the universe to appear. Space was part of the event. This is the first strange idea: the universe did not expand through space. Space expanded. Imagine drawing dots on the surface of a balloon. Each dot represents a galaxy. Now inflate the balloon. As the balloon grows, every dot moves away from every other dot, but none of the dots is the center of the expansion. From the point of view of any dot, all the other dots appear to be moving away. That is similar to what we see in the universe. Almost everywhere we look, distant galaxies are moving away from us, and the farther away they are, the faster they seem to recede. At first, this feels like proof that we are at the center, but we are not. Every galaxy would see something similar. From every location, the rest of the universe appears to be moving away. Not because everything is flying away from one special point, but because the space between everything is growing. This is why asking, "Where did the Big Bang happen?" is almost the wrong question. It did not happen over there. It did not happen at the center of the universe. It happened here. It happened where Earth is now. It happened where the Andromeda Galaxy is now. It happened in every direction we can observe. Not because matter exploded into space, but because the early universe was a hot, dense state of space itself. This is where the second misconception appears. People often ask, if the universe is expanding, what is it expanding into? That question makes sense for normal objects. A balloon expands into the room around it, smoke expands into the air, a wave expands across water, but the universe is not just an object inside a larger container. As far as modern cosmology can tell, the universe does not need to expand into anything. The distances inside the universe are increasing. The grid itself is stretching. There may be no outside. Or if there is something beyond our observable universe, we do not currently have direct access to it. This is hard to picture because our brains evolved to understand objects inside space. A rock is in your hand. Your hand is in a room. Granting the room is inside a building. The building is on Earth. Everything we know has a location inside something larger. But when we talk about the universe, that intuition breaks. The universe is not inside space. The universe includes space. So when we say the universe is expanding, we do not mean galaxies are flying through space like shrapnel. We mean the distance between faraway galaxies is increasing because space itself is changing. This also explains something that sounds impossible. Some distant galaxies can appear to move away from us faster than the speed of light. That does not mean they are breaking the rules of physics. Nothing is locally racing through space faster than light. Instead, the space between us and them is expanding. The speed limit of light applies to motion through space. But the expansion of space itself is a different kind of thing. This is why the Big Bang can be so confusing. The words are simple, but the idea is not. Now let's rewind the universe. Today, the universe is cold, dark, and enormous. Galaxies are separated by unimaginable distances, but if space has been expanding, then in the past everything was closer together. Go back far enough and the universe becomes hotter, denser, brighter, more extreme. At a very early stage, atoms could not exist. The universe was too hot. Matter and radiation were mixed together in a glowing plasma. Baud light could not travel freely because it kept bouncing off charged particles. The universe was not transparent. It was like a fog of energy. Then, after hundreds of thousands of years, the universe cooled enough for electrons and nuclei to combine into atoms. Light was finally able to travel freely. That ancient light is still around us today. We call it the cosmic microwave background. It is not light from stars. It is not light from galaxies. It is the leftover glow from the early universe, a fossil image of the universe when it was young, press-canned, and it is one of the strongest pieces of evidence that the universe really did begin in a hot, dense state. When scientists map this ancient radiation, they do not see one explosion point. They see it coming from every direction. The early universe surrounds us, not because we are special, but because every observer, just everywhere, is looking back toward a time when the whole observable universe was hot and dense. This is the part that feels almost impossible. The Big Bang is not an event we can point to in space. It is an event we look back to in time. Look far enough into space, and you are also looking back in time. Light takes time to travel. When you see the moon, you see it as it was about 1 second ago. When you see the sun, you see it as it was about 8 minutes ago. When telescopes observe distant galaxies, they see them as they were millions or billions of years ago. So when we look deep into the universe, we are not just seeing faraway places, we are seeing earlier chapters of cosmic history, and the cosmic microwave background is one of the oldest chapters we can directly observe. It is like the baby picture of the universe, but even that is not the very beginning. Before that light was released, the universe was opaque, and before that, in its earliest moments, physics becomes even stranger. Scientists have strong models for how the universe evolved from a hot, dense state, but the absolute beginning is still uncertain. We do not fully know what happened at time zero. We do not know what, if anything, came before inflation. We do not even know if before is a meaningful word when talking about the beginning of time itself. This is where the Big Bang becomes less like an answer and more like a doorway. It tells us that the universe was once hotter and denser. It tells us space has expanded over billions of years. It tells us the galaxies we see today grew from tiny early fluctuations, but it does not yet tell us why there is something rather than nothing. It does not tell us what set the expansion in motion, and it does not tell us whether our universe is the only one. The name Big Bang makes it sound like science has a simple story. First there was nothing, then there was a bang, then everything existed. But the real story is more subtle. The Big Bang theory is not really a theory of the absolute creation of everything. It describes how the universe evolved from an extremely early state into the cosmos we see today. That difference matters, because if you imagine the Big Bang as an explosion, you will ask the wrong questions. Where was the center? What direction did it explode? What is outside the blast? Where did the debris go? But if you understand it as the expansion of space itself, the questions change. How does space expand? Why is the universe so uniform on large scales? What caused the earliest fluctuations? Why did those tiny fluctuations become galaxies? And what is driving the expansion today? Those are deeper questions, and they are much closer to what cosmologists actually study. The strangest thing is that the Big Bang did not just create a universe of objects. It created a universe of distances, a universe where space can stretch, where time can have a history, where light from the beginning can still be detected as a faint microwave glow, where every galaxy carries evidence of a past when everything was closer, hotter, and more connected. So the next time you imagine the Big Bang, do not picture a bomb. Do not picture matter exploding into darkness. Picture the darkness itself changing. Picture every point in space once compressed into a hotter, denser past. Picture a universe where there is no central explosion because every place was part of the beginning. The Big Bang was not a blast that happened somewhere far away. It was the moment the entire observable universe began expanding, not from a center, not into empty space, but from everywhere, into its own future. And maybe that is the most beautiful part. The beginning of the universe is not located in some distant corner of the sky. It is behind every star, behind every galaxy, behind every atom in your body. When we study the Big Bang, we are not only asking where the universe came from, we are asking why there is a place called here, why there is a moment called now, Kawa, and why, after 13.8 billion years of cosmic expansion, a small piece of the universe became aware enough to look back and wonder how it all began.